Welcome children. Today we are going to see example 1.19, that is in page number 24. So this is important 5-mark sum for your public exam. If the function f of r goes to r is defined by f of x equal to 2x plus 7, x less than minus 2, x square minus 2, x lies between minus 2 and 3, and 3x minus 2 if x is greater than or equal to 3. So first of all, what you are going to do is we have to list out the elements. So here, if the function is 2x plus 7, then x is less than minus 2. Okay. So coming to the number line, you see the number line. So here x is less than minus 2. So if it is less than minus 2, here the equal to sign is not there. So this minus 2 is not included in the set, and x, the values of x less than minus 2 are minus 3, minus 4, minus 5, etc. Okay, that we have tried first. Then second one, if x is x square minus 2, when it is x square minus 2, if x lies between minus 2 and 3. Okay, plus 3. So coming to the number line, here minus 2 is included in the set because equal to sign is there. So minus 2, minus 1, 0, 1, 2. And again 3 is not included because equal to sign is not there. And the last one, 3x minus 2 if x is greater than or equal to 3. So this one lies. So 3 is also included, 3, 4, 5, etc. It will come, that is 3x minus 2. Now we'll see the first sum, f of 4. So here we are going to find out f of 4. For that, which one we have to write? So here only in this one, this 4 is included, 3, 4, 5. Okay. So you have to take this one. This f of x, f of 4 is equal to 3x minus 2. That you have to take, that interval. Okay. So 3x minus 2. So in the place of x, you have to substitute the value as 4. So 3 into 4 minus 2, 3 4s are 12, 12 minus 2 is 10. Okay. And the next one, f of minus 2. So where it will lie minus 2? Here only. So you have to take this one, x square minus 2. So in the place of x, you have to substitute the value as minus 2. So minus 2 the whole square minus 2. So minus 2 into minus 2, it is minus into minus plus. 2 2s are 4, minus 2, it is 2. Then the third one, here f of 4 plus 2 f1. So here already we found f of 4. So no need to find it again. Enough to find f of 1. What is f of 1? So you have to go here. So this one lies here only. So x square minus 2. So x square minus 2. So in the place of x, you have to substitute the value as 1. So 1 square minus 2. So 1 square is 1 into 1 is 1 minus 2. So 2 minus 1, it is 1, and the sign before the greater is minus. So it is minus 1. Now the question is f of 4 plus 2 f of 1. Already we found f of 4. So you have to write f of 4. Then plus is there. Plus 2 into f of 1. What is 2 f of 1? F of 1 is minus 1. See, we put right here 1. Minus, I put it here. So minus 2 into 1. So 10 minus 2, it is 8. Now the last one, f of 4 minus 3 f of 4 by f of minus 3. Already we found f of 1 and f of 4 also we found. Okay. So it is enough to find f of minus 3 alone. So for that minus 3. So where it will come? So it will come here only, the first slab only. 2x plus 7. Here only minus 3 is there. So we are putting this one. So f of minus 3 is 2x plus 7. So in the place of x, minus 3. So 2 into minus 3 plus 7. Plus into minus is minus. 2 3s are 6 plus 7. So again plus and minus. So you have to subtract. 7 minus 6 is 1. And the sign before the greater is plus. So it is plus 1. Now the sum is f of 1 minus 3 f of 4 by f of minus 3. So what is f of 1 minus 1? Minus of 3 into what is f of 4? It is f of 4 is where? Here 10. So 3 into 10 by 1. By the f of minus 3 value is 1. So minus 1 plus into minus is minus 30 by 1. Same sign. So add and put the same sign. So it is minus 31 by 1. It is minus 31. Now straight away we'll go to the exam exercise 1.4 question number 9. So that's in page number 26. You take page number 26. So here what is the sum? F of x equal to x plus 2. If x is greater than 1 and 2 if x lies between minus 1 and 1 and x minus 1 if x lies between minus 3 and minus 1. Here you see the first one, you take the number line. So x is greater than 1. So what are the values if x is greater than 1? It is 2, 3, 4, 5, etc. like that. Okay. Then if x lies between minus 1 and 1, here you see equal to sign is there. So it is minus 1, 0, 1. These three numbers are included in this one. Then minus 3 less than x less than minus 1. So here it lies between here only. Minus 3 is not included. Minus 1 is not included. So between these values, no, what are they? So minus 2, minus 1.5, like that minus 1.4. All these things are included in this one. Okay. So we'll do the first sum, that is f of 3. So f of 3 means where it lies the 3, here only x plus 2. So you have to write x plus 2, that is equal to, so in the place of x I am substituting the value as 3. So 3 plus 2 it is 5. Now the second sum, it is f of 0. So f of 0 where it comes? Here only. So what is that? If f of 0 means the value is 2, that is given. So no need of finding, no x. So simply we are writing the value as answer as 2. Now the third one is f of minus 1.5. So I told you already it lies between here only. So here minus 1.5 is here only. So you have to write here x minus 1. So what is x? X is minus 1.5 minus 1. Same sign. Add and put the same sign. So it is minus 2.5. Now f of 2. 2. Where it comes? The 2. 2 comes here only. Yes. So it is x plus 2. So 2 plus 2 it is 4. Now f of minus 2. F of minus 2 here. X minus 1. So x is minus 2, minus 1, same sign, again add and put the same sign. So it is minus 3. Now our question is f of 2 plus f of minus 2. So it is 4 minus 3, it is 1. Now the next sum under the same model, that is question number 10. F of x equal to 6x plus 1 minus 5 less than or equal to x less than 2. Then 5x square, here the sum. So here take the number line. Now we are going to list out the elements of the first one. So here x lies between minus 5 and 2. Here minus 5 is included because equal to sign is there. So minus 5, minus 4, minus 3, minus 2, minus 1, 0. Then 1. 2 is not included because equal to sign is not there. Then again the second one, 2 less than or equal to s. So here 2 is included. So 2, 3, 4, 5. Again 6 is not included because equal to sign is not there. And the last one, 6 less than or equal to x less than or equal to 9. So the values are 6, 7, 8 and 9. Both 6 and 9 are included. Okay. Now first sum, f of minus 3 plus f of 2. So first we are going to find out f of minus 3. Where that minus 3 comes? Here. So it is 6x plus 1. So 6 into, in the place of x, it is minus 3 plus 1. Plus into minus is minus. 6 3s are 18 plus 1. Now unlike sign. So subtract. 18 minus 1 is 17. Sign before the greater is minus. So it is minus 17. Now f of 2. So where that f of 2 comes? 2 comes here. So 5x square minus 1. So it is 5x square minus 1. So 5 into x square, in the place of x it is 2 square minus 1. 2 square is what? 4. 5 4s are 20 minus 1, it is 19. Now f of minus 3 plus f of 2, it is minus 17 plus 19. Unlike sign, subtract. 19 minus 17 is 2. Sign before the greater is plus. Second sum, f of 7. So here f of 7, where it comes, you have to go there. So f of 7, so 7 comes here, so it is 3x minus 4. So it is 3x minus 4. So 3 into x is 7 minus 4. 3 sevens are 21 minus 4. 21 minus 4 is what? 17. Then f of 1. So for that we have to go here. F of f of 1. Where f of 1 comes? Here. So it is 6x plus 1. Yes. So 6 into, in the place of x, the value is 1. 6 into 1 plus 1. 6 ones are 6 plus 1. 6 plus 1 is 7. So f of 7 minus f of 1. It is 17 minus 7, 10. Third question, f of 4 plus f of 8. So f of 4. So f of 4 comes the first one, no? First slab. So here, f of 4. F of 4, where it comes? So you have to go there. So it is 5x square minus 1, no? So 5x square minus 1, that is equal to 5 into x is 4. 4 square minus 1. 4 fours are 16. 16 into 5. 16 into 5 is 80 minus 1, it is 79. F of 8. F of 8 comes under this one, last one, 3x minus 4. Yes. So 3 into 8 minus 4. 3 8s are 24 minus 4, it is 20. So 2 f of 4 plus f of 8. So 2 into f of 4 is 79 plus f of 8 is 20. 79 2s are 158 plus 20, it is 178. The last one, f of minus 2 minus f of 6. 2 f of minus 2 minus f of 6 by f of 4 plus f of minus 2. So f of minus 2. F of minus 2, here it comes under the first one, 6x plus 1. So 6 into minus 2 plus 1. Plus into minus is minus. 6 2s are 12 plus 1. Unlike sign, subtract. 12 minus 1 is 11. Sign before the greater is negative, minus. F of 6. F of 6 comes under the second one. So f of 6 comes under the fourth one, no? Third one. Here, we'll see. Here only 6 comes, yes. So it is 3x minus 4. 3x minus 4. So 3 into x is 6 minus 4. 6 3s are 18 minus 4, it is 14. So 2 f of minus 2 minus f of 6. So we are going to substitute the value. 2 into f of minus 2 is minus 11. Minus f of 6 is 14 by f of 4, it is 79 minus f of minus 2, it is 11. We already got. So plus into minus is minus 22 minus 14 by 79 minus 11 is 68. Same sign, add and put the same sign, minus 36 by 68. Now this minus 9 fours are 36, 17 fours are 68. Then now we'll go to the first sum under this exercise. So determine whether the graph given below represent functions. Give reason for your answers concerning each graph. So here the graph is given. See the book, it's page number 25. So one graph is given. Yes, just like that one graph is given. And to find whether this graph represent a function or not, you have to draw a vertical line like this. So you have to draw a vertical line. Here I am drawing the vertical line. Yes, this is the vertical line. Now, this vertical line meets the curve at 2 points. Yes, the 1 point, another 1 point. Therefore, it is not a function. If the vertical line meets the curve at only 1 point, then we can say it is a function. So here, this vertical line meets the curve at 2 points. So it is not a function. So second sum, here again, one graph is given. Yes, like that, here one graph. So we are drawing a vertical line. I am drawing the vertical line here. This vertical line meets the curve at only 1 point. Yes. So here this is the curve. This is the curve, and this vertical line meets the curve at only one point. Therefore, it is a function. Then third sum, here the graph. Yes, and I am drawing the vertical line. Here this vertical line meets the curve at one and this one more point and this one more point. So this vertical line meets the curve at more than one point. Therefore, it is not a function. If the vertical line meets the curve at only one point, it's a function. Otherwise, it's not a function. Then the last sum. So here again, you have a graph. You have a curve like this. Here one straight line, no? And we are drawing a vertical line. This vertical line meets the line. So here it is line at only one point. Therefore, it's a function. Then the second sum under the same exercise 1.4. Here A is equal to, here this again another 5 marks. So first we had seen 3 sums, no? That is 5 marks sum. Another important model, that is here the second sum. 2, 4, 6, 8, 6, 10, 12, and B is another one set. And the f of x, the function is given as x by 2 minus 1. So here, for first you have to take the first element of the set A, f of 2. Substitute the value here. In the place of x, 2 by 2 minus 1. 2 by 2 is 1. 1 minus 1 is 0. Then f of 4, second element, 4 by 2 minus 1. 4 by 2 is 2 minus 1, it is 1. F of 6. 6 by 2, it is 3 minus 1, it is 2. Then f of 10, it is 5 by 10 by 2 is 5 minus 1, 4. Then 12. F of 12 is 12 by 2 minus 1. 12 by 2 is 6 minus 1. It is 5. Now what we are going to find out? We are going to find out the set of ordered pairs. For that, what you are going to do? It is very easy. Simply you have to write f is equal to, take the first element. Here x. So if x is 2, what is f of x? It is 0. If x is 4, what is f of x? 1. If x is 6, what is f of x? 2. 6 comma 2. If x is 10, what's the value? 4. If x is 12, what's the value? It is 5. So this is the set of ordered pairs. Now table form. You have to write this one in the table form. X, f of x. So if it is 2, it is 0. If it is 4, it is 1. If it is 6, it is 2. If it is 10, it's 4. And if it is 12, it is 5. Very easy. Then the arrow diagram. For that, you have to draw the set A and the set B. So for drawing the arrow diagram, one thing to be followed, you have to write all the elements of A in the set here, A set. Then in the B set, you have to write all the elements of B. Okay. Then when you are mapping, so here when you are drawing the arrow diagram, 2 to be matched here, 2 comma 0, 4 comma 1, then 6 comma 2, 10 comma 4, and 12 comma 5. Remember that this 9 is left over, let it be like that. But it is very important to write 9 in the set B because it is an element of the set B. Then the graphical representation. For that, just like our graph sheet, how we drawn, no? In the same way, here in the A set to be, the set A to be taken in the x-axis and the set B to be taken in the y-axis. So here 2 comma 0. 2 comma 0 is on the x-axis. Then 4 comma 1, 6 comma 2, 10 comma 4, and 12 comma 5. Remember that when we are drawing the graph, you have to take 2 centimeters in between the points, 2 centimeters here and here also the same thing, so that our diagram will be very nice. Then the third sum, represent the function is given, function is given 1 comma 2. So function, the ordered pairs is given here 1 comma 2, 2 comma 2, 3 comma 2, 4 comma 3, 5 comma 4. We have to draw the arrow diagram first. So for that, so in the ordered pair, the first element belongs to the first set. Yes. So 1, then 2, then 3, then 4, and 5. This one belongs to set A. That only I am listing out here. Then B is second ordered per second element. 2, here again 2, 3, 4, 2, 3, 4. So we are writing A set 1, 2, 3, 4, 5 and B set 2, 3, 4. And we are matching this one 1, 2, 2, 2, 3, 2 and 4, 3, 5, 4. See this one. See this ordered pass and draw this arrow diagram. Then the table form. Here again, you see the first one. The say ordered pair only. X and f of x. 1, 2, 2, 2, 3, 2, 4, 3 and 5, 4. That's all. Then the graphical representation is also asked here. So I think you can draw this one graph here. So the graph is 1, 2, 3, 4, 5, 4, 6. No, here in the x-axis and the y-axis 1, 2, 3. Here you have to take 2 centimeters. Okay. Then 1, 2, 2, 2, 3, 2, 4, 3, 5, 4. You know how to plot the points in the graph sheet. The same way you have to draw. Then fourth sum, show that the function f of n goes to n defined by f of x equal to 2x minus 1 is 1, 1 but not on 2. So here the function is n goes to n. So natural number to natural number. So f of x equal to 2x minus 1. So if we want to show the function is 1, 1, it is enough to show that x1 is equal to x2. For that, first you have to write f of x1 that is equal to f of x2. Like that we are taking. What is f of x? It is 2x minus 1. So what is x1? F of x1 means in the place of x, you substitute the value as x1. So 2x1 minus 1 equal to, what is f of x2? 2x2 minus 1. This 1, 1 get cancelled, 2, 2 get cancelled. So therefore, we are getting x1 is equal to x2. Therefore, if we get x1 is equal to x2, then we can say f of x is 1 to 1. Now, what is the other one? But not on to. So for that, we are taking example. First, we have to take f of 1. What is f of 1? 2x minus 1. Here only you have to substitute, yes? So f of 1 is equal to 2 into 1 minus 1. 2 ones are 2 minus 1, it is 1. What is f of 2? 2 into 2 minus 1. 2 2s are 4 minus 1, it is 3. What is f of 3? 2 into 3 minus 1. 2 3s are 6 minus 1, 5. What is f of 4? 2 into 4 minus 1. 2 4s are 8 minus 1, it is 7. Now, we are drawing the arrow diagram. First, here the function goes from n to n. So, natural numbers 1, 2, 3. Here also 1, 2, 3. Like that, it is going on. Now, if you take 1, if x is 1, what is f of x? It is 1. If x is 2, what is f of x? It is 3. Yes. If x is 3, what is f of x? It's 5. In the same way, if x is 4, f of x is 7, like that. Now, different values of x in here, this is the domain and this is the codomain. Yes. Domain, codomain. First set is domain. Second one is codomain. Our f of x is only codomain. So different values of x in the domain has different images in the codomain. Therefore, f is 1, 1. Already we 1 to 1. Already we wrote this one. Now, here you see 2 belongs to n. Yes, in the codomain. 2 is a element in the codomain. Yes, but it does not have a pre-image in the domain. It does not have a pre-image. 2 does not have a pre-image. Yes. So it is not on 2. So if it is on 2 means every element in the codomain has an image in the domain. But here 2 does not. 2 is in the codomain, but it does not have a pre-image in the domain. Therefore, it is not on 2. In other words, even numbers in the codomain. See 2, 4, 6. Even numbers in the codomain does not have pre-image in domain. Therefore, it is not on 2. But it is 1 to 1, but it is not on 2. Okay. Then again we'll do example 1.11. In example 1.11, that's in page number, that's important 5 mark sum, page number 16 you take. So here very easy sum. A is equal to 1, 2, 3, 4 and B is equal to 2, 5, 8, 11, 14. So here the function is f of x equal to 3x minus 1. So what is f of 1? 3 into 1 minus 1. 3. 3 ones are 3 minus 1, it is 2. What is f of 2? 3 twos are 6 minus 1, it is 5. What is f of 3? 3 threes are 9 minus 1, it is 8. What is f of 4? 3 fours are 12 minus 1, it is 11. Now we are going to draw the arrow diagram. For that, A set 1, 2, 3, 4, B set 2, 5, 8, 11, 14. So here 1 means it is 2, 2 means it is 5, 2, 3 means what is that? 8. Then 4 means it is 11. Table form. Again x and f of x. So 1 means 2, 2 means 5, 3 means 8, 4 means 11. So here again, when you're writing the drawing the arrow diagram, don't forget to write the number 14. Now the set of ordered pairs f is equal to 1, 2, 2, 5, 3, 8 and 4, 11. Now the graphical representation 1, 2, 3, 4, 5 like the same thing you have to draw. So what is 1, 2? Like the 2, 5, 3, 8, 4, 11 to be plotted. Now coming to the exercise 1.4 fifth sum, page number 25. So here so that the function f of n goes to n defined by f of m is equal to m square plus m plus 3 is 1 function. It's a 1 function. So here first you can take first number f of 1. So since it is natural number, no, so it starts with 1. F of 1 we can take. So in the place of m, the substitute the value as 1. 1 square plus 1 plus 1. 1 square is 1. 1 plus 1 is 2. 2 plus 3 is 5. Then in the place of m, you have to substitute 2, f of 2. So 2 square plus 2 plus 3. 2 square is 4 plus 2 plus 3. So it is 9. Then f of 3, 3 square plus 3 plus 3. Here we are substituting, yes, 3 square. 3 square is 9 plus 3, 12 plus 3, 15. F of 4, 4 square plus 4 plus 3. 16 plus 4 plus 3, it is 23. Now, we are drawing the arrow diagram. 1 means it is matched with 5. Then 2 means it is 9. 3 is 15. Like that it is going on. Every element in the domain has a different pre-image in the codomain. Yes. Therefore, it is a one-to-one function. So, when do we say it's a one-to-one function? If every element in the domain has a different pre-image in the codomain. So, it is a one-to-one function. Now, sixth sum. Let A is equal to sixth sum. A is equal to 1, 2, 3, 4 and f of x is given as x cube. So here first we have to substitute f of 1, 1 cube. 1 cube is 1. F of 2 in the place of x 2 cube 8. F of 3, so in the place of x 3, so 3 cube is 27. F of 4, 4 cube is 64. Now f, the function we have tried, f is equal to 1 comma 1 means f of x is 1, 1 comma 1, 2 comma 8, 3 comma 27 and 4 comma 64. Now the range, what is the range? Range means the second component, yes. So it is 1, 8, 27 and 64. Already we wrote in the previous exercises range of f. Now every element of A has a different pre-image in the set B, yes. So it is 1 to 1 and into function. 1 to 1 and into function. Okay. Now, so here the range we found, and the second question is identify the type of function. The function is 1 to 1 and into function. Now the seventh question, each of the following state whether the function is bijective or not. Justify your answer. So what is the meaning of bijective? Bijective means it is 1 to 1 and on to. Bijective means what? It is 1 to 1 as well as on to. So we'll check. First sum, f of x equal to 2x plus 1. So I told you already, if it is 1 to 1, then it is enough to show that x1 is equal to x2. For that, we are taking f of x1 is equal to f of x2. So what is f of x1? 2 in the place of x, 2x1 plus 1 equal to x2 means 2x in the place of x, you have to substitute 2x2 plus 1. Now 1 get cancelled. So it is 2x1 is equal to 2x2. Again, this 2 get cancelled. Okay. So you are getting x1 is equal to x2. Therefore, it is 1 to 1. Now for bijective, one more we have to prove, that is it is on to also you have to prove. Let y is equal to 2x plus 1. That is given. Now from that we are taking this, we are bringing this 1 here. So it is y minus 1 is equal to 2x. Now what is our x? X is equal to y minus 1 by 2. So every y belongs to R in codomain, there exists pre-image y minus 1 by 2 belongs to R in domain. So it is onto. Therefore it is bijective. Therefore it is bijective. Now the second sum, f of x is equal to f of x is equal to 3 minus 4x square. So here f of 1 is equal to, what is f of 1? It is 3 minus 4 into 1 square. 3 minus 1 square is 1, no? So 4 ones are 4. 3 minus 4, what it is? It is minus 1. Then f of, so we are taking some of the examples. Okay. So f of minus 1. What is f of minus 1? 3 into minus 4 into minus 1 the whole square. Again, this minus into minus plus. So 3 minus 4, it is minus 1. In the same way, what is f of 2? 3 minus 4 into 2 square. So 3 minus 4 into 2 square is 4. 3 minus 4 4s are 16. So 16 minus 3, it is 13. Sign before the greater negative. So minus. F of minus 2, what it is? 3 into 3 minus 4 into minus 2 the whole square. So 3 minus 16, it is minus 13. Now we are showing the arrow diagram. Minus 1, 1, 2, minus 2. What is the pre-image of minus 1? It is minus 1. Here minus 1 it is. Here, what is f of minus 1? It is also minus 1. Here minus 1. Minus is here. So minus 1 is here. Here also, what is for 2? What is that? 2 answer is minus 13. For minus 2 also the answer is minus 13. So here it is, remember it is minus 1 here. Minus 1, minus 13. So it is not 1, 1. Why it is not 1 to 1? Because two different values in the domain has the same image in the codomain. So here two different values, minus 1 and 1. It has only the same pre-images, same image in the codomain. So it is not 1 to 1. Therefore, it is not bijective also. If it is bijective means it is both 1 to 1 and on to. Here, first of all, it is not 1 to 1. So it is not bijective. Now the eighth sum. So here a is equal to minus 1 comma 1, b is equal to 0 comma 2. Now f of x is ax plus b is onto function. Find a and b. So it is given it's onto function. Now what is f of x? It is given ax plus b. Now f of minus 1 in the place of x, a into minus 1 plus b equal to plus into minus 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 a plus b, that is equal to, here this is onto. So onto means what? This one, this b, the pre-image of this one p is here only. So f of x, in other words, if x is minus 1, then f of x is 0. So this first element to be equated to this one first element. So minus a plus b equal to 0. Then second, f of 1, a into 1 plus b. A into 1 is a plus b equal to, here the second, what is the answer? 2. Now here first equation, second equation, just add these two equation, minus plus get cancelled. Now b plus b is 2b equal to 0 plus 2 is 2. That implies b is equal to, this one goes to the denominator if it goes to the other side. So it is 2 by 2, it is 1. Now we substitute b equal to 1 in 2. What is that? B is 1, a plus 1 is equal to 2. So a is equal to 2. I am bringing this plus to other side. It becomes minus 2 minus 1 is 1. So the answer is a equal to 1 and b equal to 1. Now, the 12th sum, the last sum. So, F is equal to 9 by 5 Celsius plus 32, the temperature. We are going to find out what we are going to, and it is given T of C equal to F. It is given in the sum itself. And we are going to find out T of 0. What is T of 0? So, in the place of this one C, you have to put the value as 0. 9 by 5 into, so here T of C is equal to F, it is given, yes. So, T of 0 means 9 by 5 into 0 plus 32. So, it is 0 plus 32, it is 32 degree Fahrenheit. Now, T of 28. So, in the place of C, substitute the value as 28. So, if you multiply 28 nines are 252 by 5. So, if you divide, it becomes 50.4 plus 32, it is 82.4 degree Fahrenheit. Now, T of minus 10. So, again 9 by 5 into minus 10 plus 32. So, this 5 and minus 10. So, my 2 times here. Now, minus plus into minus minus, 9 twos are 18 plus 32. Unlike sign, subtract. 32 minus 18 is 14. Sign before the greater is plus 14 degree Fahrenheit. Now, find the value of C when T of C equal to 212. So, here you have to substitute 9 by 5 C plus 32 equal to, it is given as 212. So, 9 by 5 C equal to 212 minus 32 plus 32, if it goes to the other side, it becomes minus 32. If we subtract, you will get 180. Now, what is our C? 180 into this numerator, denominator goes to the numerator, and this numerator will come to the denominator. And if I cancel this 9 with 18, 2 nines are 18, 0. 20 into 5 is 100 degree Celsius. Now, the last one, the temperature when the Celsius value is equal to the Fahrenheit value. So, here it is given the Celsius is equal to Fahrenheit. So, C is equal to F, it is given. So, in the place of C, I am substituting the value as F. And what is our F? It is 9 by 5. So, here again, in the Celsius, you have to substitute the value as Fahrenheit. Because C is equal to F, it is given, plus 32. So, 9 by 5. I am bringing this F to that side, it becomes minus F. This plus 32, if it comes to this side, it becomes minus 32. Now, take the LCM, 5 becomes the LCM. So, it is 9F minus 5F equal to minus 32. Subtract 9 minus 5 is 4F by 5 equal to minus 32. F is equal to minus 32 into this denominator goes to the numerator, and this numerator will come to the denominator. 8 4s are 32. So, minus 40 degree. That's all under the exercise 1.4. Hope you understood this one.